The objective of our lesson for today is solve problems using of analytical, numerical, and graphical techniques. First, what is limit? The limit of a function is a fundamental concept that describes the behavior of a function as its input, usually denoted as x approaches a particular value. Here are the three methods in limits of function. First, numerical. The numerical method for evaluating limits of a function involves approximating the limit by computing the function's values near the point of interest. Second, analytical. This is a mathematical approach to calculate limits using algebraic techniques, simplifications, and limit rules. Okay, now let's proceed to the limit laws of analytical method.
Limit laws. The limit of a constant is a constant itself. Identity. The limit of x as x approaches is c. Constant multiply. The limit of a constant multiplied by a function is the constant multiplied by the limit of the functions. Power. The limit of a function raised to a power is the limit of the function raised to that power. Root. The limit of a root of a function is the root of the limit of the function. Sum and difference. The limit of the sum or difference of two functions is the sum of difference of their limits. Product rule. The limit of a product is the product of their limits. Quotient rule. The limit of a quotient is a quotient of the limit if the denominator is not zero.
Lastly, graphical. In this method, the graph of the function is used to visually examine the behavior of the function as x approaches a certain value. Now that we all know the definitions of the three methods, let's proceed to examples for us to know how those method works.
We have here the example of numerical method, the limit of x minus 3 over x squared minus 3 as x approaches to 3. Let's move on to the table. We have here 3 values that's approaching to left side and 3 values for the right side. And in the middle, we have 3 since x approaches to 3. The closest value of 3 in left side that I solved is 2.999, 2.99, and 2.9. For the right side is 3.001, 3.01, and 3.1. And now, let's know how we solve for the value of f sub x. The first one is 2.9. Now apply the 2.9 to our equation, which is limitation of 2.9 minus 3 over 2.9 squared minus 2.9 minus 3, and the answer is negative 0.039.8. The second one is 2.99. Let's apply our equation to 2.99 minus 3 over 2.99 squared minus 2.99 minus 3 is negative 0.0034. For our third value in left side, we have 2.999. Apply the equation, which is 2.999 minus 3 over 2.999 squared minus 2.999 minus 3 is negative 0.0003. On the right side, we have 3.001. Now apply the equation 2.001 minus 3 over 3.001 squared minus 3.001 minus 3 is 0.0003. The second value is 3.01. Apply again the equation 3.01 minus 3 over 3.01 squared minus 3.01 minus 3 is 0.0033. Now, for our last value from the right side, we have 3.1. Apply to its equation 3.1 minus 3 over 3.1 squared minus 3.1 minus 3. That will give us 0.028. That will give us 0.0285. Now, we can see in our table of values that both from right and left approaches to 0, which means that the limit does exist. Here's some example of analytical. Constant. The limit of a constant is itself. Here's example. The limit of negative 60 as x approaches to 10 is equals to what? From k, the answer is 10. The identity. The limit of x as x approaches is c. The example is the limit of x as x approaches to 4, and the answer equals to 4. From c is identity. Constant multiple. Now, in the constant multiple, example is the limit of 5x as approaches to 2 equal to what? Use constant at first and the answer is 5. Now, from formula of law, copy the constant multiple 5 multiply the limit of x as approaches to 2. The answer is 2x. Next, it's time to multiply the answer. 5 times 2 is equals to 10. That's all. Thank you.
The first limit x approaches to 3 from the left, f of x is the limit of the function as x approaches 3 from the left. The value of this limit is 2. This means that as x gets closer and closer to 3 from the left, the value of the function gets closer and closer to 2. The second limit x approaches to 3 to the right, f of x is the limit of the function as x approaches to 3 from the right. The value of this limit is also 2. This means that as x gets closer and closer to 3 from the right, the value of the function gets closer and closer to 2. The third limit x approaches to 3, f of x is the limit of the function as x approaches to 3 from the either side. The value of these limits is also 2. This means that as x gets closer and closer to 3 from either side, the value of the function gets closer and closer to 2. Finally, the expression f of 3 is equals to 4 is the value of the function as x equals to 3. This value is not equal to the limit of the function as x approaches to 3. This means because the function is not defined at x equals to 3. The graph shows a function that has a vertical asymptote as x equals to 3. The limits of the function as x approaches to 3 from either side are both 2. The value of the function at x equals to 3 is 4. The graph shows a function that is defined for all values of x except for 3 equals to 3 at x equals to 3. The function has a vertical asymptote. This means that the function approaches infinity as x approaches to 3.
Now that we already know how it works, before we end, let's try this and check your answers. That's all for our discussion. We hope that you get and learned something from us. Thank you and have a great day.